Hi everyone. In this video we are going to look at section 4.4, simplifying radicals. Specifically we're looking at example 6b. We have been asked to simplify and state the restrictions. So let's start by stating the restrictions for 6b. Let's have a look. We have the square root of 8 times x to the power of 5 plus 3 times the square root of 50 times x to the power of 5. Okay, so let's have a look at what we're dealing with, specifically paying attention to the first radical where we have x to an odd power, and we're taking the square root of that odd power. So anytime you are taking the square root of an odd power, your restriction is that x must be greater than or equal to 0. Otherwise, you would be in a situation where you would be trying to take the square root of a negative number, and that's not possible. Furthermore, let's look at the next one. We have the same situation. We have an odd power, which is 5, and we are taking the square root. So the same rule applies. Therefore, our restriction for this 6b is that x must be greater than or equal to 0. Okay, so now we can go ahead and start solving this problem, start simplifying it. So because we are taking the square root, we want to try and separate out our variables as a product of an even power and an odd power. So all we really need to do is we need to write x to the power of 5 as x to the power of 4 times x to the power of 1. And of course we can also rewrite 8 so that we have a perfect square. So all of this is just to make it easier when we try to take the actual square root. So to make this a little more clear, we're going to write this square root of 8 as the square root of 4, just extend that a little bit, times the square root of 2. And we'll write the portion that has the variable as x to the power of 4 times x to the power of 1. And again, I just need to extend my radical sign just a little. Okay, so that takes care of the 8 times x to the 5, right? This would be 8. And this, if you added the exponents together again when multiplying, you'd have x to the power of 5. We're adding this, of course, to the next one where we have 3 times the square root of, well, let's consider 50. If we were to write it as a product of a perfect square and some other number, we would write it as 25, which is a perfect square, times 2. And we'll multiply that by x to the power of 4 times x, or rather the square root of that product. Okay, so now we can start simplifying. Let's go ahead and take the square root of our perfect square, 4. The square root, of course, would be 2. So now we have 2 times the square root of 2. Here, if we take the square root of x squared, of x to the power of 4, we would have x squared times the square root of x, which is still inside, and of course we cannot take the square root of x to the power of 1. Moving on, we would have 3, and in this case the square root of 25 would be 5. We're multiplying that with what's left on the inside, which is the square root of 2. And if we take the square root of x to the power of 4, again we would have x squared times the square root of what's left over, which would be x. Okay, so we're well on our way. We just need to do a little bit more simplification and bringing things together. Okay, so now we can combine what we've taken to the outside of our square root. So for this first part, we will write 2x squared, and then what still remains inside the square root would be 2x coming from here and here. We're adding that, of course, to what's on the outside here, which would be 3 times 5, which is 15. And here we have x squared, so we've pulled all of that outside of the square root. And then still left on the inside would be 2 and x, okay, from here and here. So we're almost done But I hope you notice that now we have like terms because we have 2 times x squared times the square root of 2x plus 15 times x squared times the square root of 2x. So because this is the same as this, we can add 2 and 15 together. So we end up with 17 times x squared times the square root of 2x. And that is our final answer, as we've already stated that our restriction is x has to be greater than or equal to 0.